awesome gang of really great students, but it's also like a giant distraction from this class. So I encourage you to support the Forge and follow your school newspaper, but not right now. Let's dispense with the distractions, please. And while we're not reading the Forge, I want to point out a couple of things. Yesterday, I wrote some basics of biogeography. The example was marsupials in Australia, but this is true of chameleons in Africa and iguanas in South America. Did we already talk about these three things as separate concepts yesterday? You might notice that these were the three parts of the answer to the marsupials. And so you probably want to have this with any notes you might have taken yesterday. I think that's useful. And then a lot of kids asked me to spell this yesterday. The relationship between the moth that needs the flower and the flower that needs the moth. It's called obligatory symbiosis, and each of the species is called an obligate symbiont. So you might want to throw down some of this on yesterday's notes and this vocab if you were writing anything about the moth or the other thing. I'm sorry, SPP?
Yeah.
That's multiple species.
What's the word after change? That is spelled over.
Okay, anybody want to talk to me more?
So is it saying that the species occupy the same niche even as they evolve?
Check you out, you're a frosh. Do they occupy the same niche? Yeah, sequentially. So if it's a good idea to be a Ferrari mechanic and your Ferrari mechanic goes out of business, someone else will probably move into town and become a Ferrari mechanic. And like we saw in that weird drawing yesterday, if it makes sense for a dinosaur to be a chase animal and prey on things, it probably makes sense for a mammal to move into that niche too. There might be some giant cockroach dolphin thing after the humans are gone.
I don't like that.
Oh, I like that. Okay, kids. So let's move on to the chlorophyll here.
What? Oh,
More like chlorophyll?
chlorophyll.
In yesterday's assignment, 3.1, I got to finish talking about the stuff I wanted to talk about, but there were a whole bunch of 1 through 10 questions. And frankly, I kind of feel like you could do it with the book, but if some of you had questions, I'm prepared to answer them. I just didn't have lecture lined up. So questions from 1 to 10 on yesterday's assignment? Sorry, on 3.1?
It was 3.3.
That was yesterday's. You're right. I made a mistake. On 3.1, which was Wednesday's assignment. Are there any questions on Wednesday's assignment 3.1? Yeah.
For number 3, when it says house animal class on plants, whatever.
Yeah.
Is the answer in Wallace's realms?
That's fine. And by the way, the concept I wanted you to have is that they are independent.
Each realm.
Right. That the major land masses have their own set of animal and plant distribution. That they have their locals, their weird regional specifics. Hey, Jack, I have a little jobby job for you. Other questions?
Step number 1, you cut these into strips. And step number 2, deliver them to the classrooms. And step number 3, when you're there, verify that the number of desks, like these, 3 desks, is accurate. Or the number. All I care about is the number. If you can't do any, bring back the slips while noticing something later.
No other vocab or no other questions on 3.1? I like it when you don't ask questions. I can just do my own thing.
What is a biological world class?
We'll do that as a study goal when we're doing biomes.
Okay.
What else? Okie dokie. Today we start our tour of biomes, which is your 3.3. Yeah.
Sorry, I was just.
Unless Alessio needs more attention. What is Alessio?
I need attention. I have
Yes, I'm here for you. What do you need?
question.
Yes.
So an ecological island can be not necessarily like an actual island. It can be like a body of water. It can be an ecological island.
Well, yeah. I mean, a park in the middle of a city is an ecological island. Sure.
Okay. So
Um,
just anything that's like.
The whole point is that it's not a geographical island.
Okay.
The big distinction is some islands are land and sea. Haha, party foul. Everybody point at the party fouler. Party foul. Foul with party foul. Everybody throw a rock at the party fouler. Yeah.
Cool.
Number 6, what other factors affect patterns of life on large land masses?
Well, so distance from the equator, amount of rainfall. I got a whole list for you. Plate tectonics, the topography, like whether you have mountains and valleys, which are a lot of little geographic isolation pockets, or whether the topography is really flat, so it's one big biome. Other barriers to migration, like the number of rivers and the number of canyons, things that isolate populations within your continent. So how many little subdivisions you get. Proximity to the ocean or another large body of water. Ocean currents if you're near the shore. Latitude and longitude make a difference too.
So it's like a lot of the things that are talked about in number 2, like climate, latitude, or in number 10, sorry.
Yeah, exactly. Exactly. Anybody have any other questions? Or are we doing this? What do you want? Yes,
I was convergent evolution.
That's when two different evolutionary pathways lead you to the same set of adaptations because you're solving the same problems with the same solutions. Convergence is like...
so does that mean, could it be, do they have to be in the same ecosystem or same?
Usually that's in the same biome, but not necessarily in the same place at the same time. Convergence was like dolphin and the dinosaur. Did we do that one yesterday?
Yeah.
So
That's convergence. They both came up with the same adaptations because they're solving similar problems.
Oh, but they're not related to each other.
They're not related. That's exactly point number 1.
Okay.
And they don't have to be in the same biome at the same time as long as they're the same concept biologically.
Divergent started with one species and then they got separated.
Yeah, divergence is getting more and more different. Convergence is getting more and more alike. Yeah.
In the book it said that convergent and divergent both increase biodiversity, but convergent can do that?
Yeah, I mean, there's still 2 different species. I don't think that convergence is necessarily... Well, yeah, there's still 2 different species. it's not like you're going to shrink diversity. Like two
Yeah.
species are going to become one somehow. They don't
Okay.
fuse.
Yeah.
Who else? I mean, it's still evolution. You're still coming up with species. It's just either going to be more similar or more different, but they're still species. Okay, so let's do the biome thing. If you remember this from your book, you'll notice that at the Arctic, there's just one biome. Look at the top of the pyramid here. Just one biome, because anywhere you are in the Arctic, it's still Arctic. But look down here. When we go down to the equator at the end of this slideshow, which is going to take like 3 days, by the way, when you get to the end of the slideshow, you'll notice that you're staying at the same latitude. The equator is the equator. But depending on how far you are from the ocean, you have different amounts of humidity. So in the equator, you can be perfectly dry, and we call it a desert, or you can have rain every day, and we call it a rainforest, or all these other things in between. So when you look at the map, and you follow across the equator, a walk around the Earth's midline would give you a bunch of different biomes. But a little loop around the North Pole is still going to be the same biome. That's probably kind of obvious, right? Like, not rocket science. We're moving on with that. Yeah.
So like, the same thing happens for going south of the equator. Like it's like it's like a mirror image, like a reflection of clouds, right?
Oh yeah. And as a matter of fact, there are species that capitalize on that. They come from one biome on the bottom, and they'll skip them all to find the same place 6 months later at the top. It's like the endless summer concept. There are many birds and whales that are just skipping the entire middle because they're trying to land in summer before they get to the other summer, before they get to the other endless summers.
Oh, because the seasons are switched, kind of? Okay.
Yes. Anybody else? Okay. I want you to develop this ability to think of what the biome feels like. A lot of times if I say like desert or rainforest, you already have some ideas. I'll hopefully give you more details in the class. But you know, temperature and rainfall are the beginning of defining a biome. This is where everything starts. It's the physical reality. Those are the real questions. The temperature and the rainfall. That's the nuts and bolts biologically. So you can see that this graph of two axes, temperature on one and rainfall on the other, captures all the biomes. The hottest and rainiest is what we call tropical rainforest. The coldest and driest is the tundra. Do you guys know that the driest place on Earth is the South Pole? Yeah. And there's two things I want to point out before we leave here. Thing number one is that the desert has the most temperature variation. Everybody knows that the desert's really hot, but a lot of people forget that the desert's also really cold. In a given day, the desert can change as much as 100 degrees in temperature. I've had my water bottles freeze at night and seen the temperature be over 100 in the desert many times. And that wouldn't have been necessarily extreme weather. We're talking like nice visiting time in spring. So notice the extreme variability of the desert's temperature. We'll come back to that. For all of your biomes, I want you to think about it like this. There's like a 3-step logic to discussing the biomes. What is the physical reality? And that will explain the selective pressures. Then how does evolution respond to those selective pressures? That's the adaptations that are specific there. And then given all those adaptations, what's that mean for humans? Is that a place where we find food? Is that a place where we find lumber? Is that a place that the dirt happens to be better? Our ability to use the biomes is based on the ecology, and the ecology is based on how it evolved, and it evolved because of the physical reality. It's not rocket science, but I want to make sure that you think of the biomes in this way. So we'll start with the tundra. It's the blue one. All the way at the top, all the way at the top, all the way at the bottom. And by the way, how is polar climate happening right there on the equator? How do we have blue Arctic at the equator? Yeah, that's right, because there's two ways to get really cold. You can go north and south, or you can just go uphill. So you'll notice the major mountain chains are also blue. There's two types of tundra. They're called Arctic and Alpine. My PowerPoint is about Arctic tundra, but much of the same is true in Alpine tundra. The big deal about the Arctic is the extreme seasonality. That's a part of this answer. And now that we're talking about extreme seasonality, did anybody answer the study goal on Monday? Sorry, the warm-up on Monday? Excuse me. Did anybody answer the warm-up on Monday?
No.
Yeah, well, I said it's
not
the
right.
positioning around the Earth, of the Earth around the Sun.
So Alessio said the positioning of the Earth around the Sun, and yeah, but there's one detail that you didn't
And
draw.
also that the Earth is tilted.
Yeah, the angle of the dangle. Our planet goes around the Earth on what's called... Our planet goes around the Sun on what we call an orbital plane. Meaning that the thing's always spinning on basically what you would call a pretty flat circuit. That plane doesn't change. Coincidentally, each of the planets is a little bit off kilter. So there's a couple planets that are like way out here. And so they go up and away and down and away. But most of them are on the same orbital plane. They're basically on the same flat circuit. Coincidentally, I'll tell you now that the solar system is full of irregularities. So you know our orbit is not circular. It's actually kind of stretched out. And you guys know that the planet's not round?
Yeah.
It's actually shaped sort of like an egg.
Is that how we know that the planet is tilted? Because if it was just a circle and it was like that, it would sort of look like a circle.
Yeah. Well,
I mean, like a sphere, not a circle.
We know that the planet is tilted because seasons forced us to notice. So you can explain seasonality in a way that lets you measure the tilt. So that the tilt is known by the fact of seasons.
Okay.
The irregularities are known by the glory of nerds. Yes?
Why does the tilt give us seasons?
I was hoping you would ask me that. I look forward to this day all year long. Hey, Mark!
Yeah.
Hit the door, bro.
oh, does it have like a light? Yeah. That's
I wish it was really dark. Because if it was really dark, this would be really, 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 really even better. Okay, so remember, first of all, that when the Earth spins, we call that a day. It takes 24 hours. A little bit of chump change. 24 hours, a couple of seconds. So there goes the Earth. Many, many, many days. One revolution around the sun is called a...
Year.
That's right. don't try to make any sense of the moon's rotations. They follow their own rhythm. And the gears got chingered, so I'm not sure that that's accurate. And whatever is this thing, Uranus.
Uranus is farther, isn't it?
Talking about my anus.
It's farther from the sun to Earth, so that's all I'm trying to say.
I know exactly where my anus is, thank you.
Is there a light supposed to be on in second?
Oh yeah, let's turn on the sun.
Oh, yeah.
Oh wow, it's blinding.
And we will notice a few things.
Daytime in Asia.
One of the things that we will notice is that there's a time of the year, like a part of the circuit around the sun, where the northern hemisphere is in the sunlight all day long. Watch. If you were a human standing right there, you'd be in the sun for an entire rotation of the Earth. Right now, this nut is creating a little bit of shade right here, but you realize that there isn't a big old hex nut on the top of the planet, right? So here we're going to have one day. And in that one day, which is not actually, the gears don't work right. In that one day, you'll notice that it's still been sunny 24 hours long, right? That the Earth spun one rotation that's 24 hours. And in those 24 hours, there was sun, for actually quite a few days. Anybody ever seen that vampire movie, 30 Days of Night?
Yeah.
Okay, so first of all, that is like the best vampire movie in the history of vampire movies, just saying. Like, we'll come back to this thing, but I gotta get this off my chest. I don't think a 400-year-old vampire is gonna want to hide out in a high school to flirt with 17-year-old chicks. Like, no offense, you're all lovely, and I know that many adults target young women and all, but 400 years, you think that the bro's gonna want drama like that? Twilight didn't seem in the least bit feasible to me.
That's why they go to Alaska.
We're also vampires. Spoiler.
That's why if you show me a vampire movie where the vampires are like dour and grumpy and like full of rage and resentment and pessimism, that makes sense to me. That's the kind of vampire I can think of. So you should all watch 30 Days of Night. It'll make your skin crawl. It made me want to throw up. It had a little bit of gore. I would say,
It is cool though.
yeah, on the gore factor, I'd give it like a 7, maybe an 8. You guys see horror movies that are way gorier. And it doesn't have a lot of like the suspense, like sneak up on you stuff. A little bit.
What's the best thing about it then?
Okay, back to me. You know the one thing that made 30 Days of Night like the best vampire movie ever? The understanding like what it would actually be like to be a vampire trapped in the dark forever, having to prey on humans. Like the best thing about 30 Days of Night is how they made the characters of the vampires. I tried watching the Twilight thing, like everybody knows Twilight, and I was like, sure, I'll try. I started every one of those movies at least 1 or 2 times, 3 times.
The last one's so good.
Whatever. Like, I can't get with that. Like, seriously, romance drama?
No,
Like,
it's a crazy plot twist.
oh, what's her face is hot. That helps. But okay.
Yeah, so
Okay. Back to me. Me. Okay. So, sorry to talk about vampires. But there's actually this little circle at the top that never goes in the dark for many days in summer. And you guys, of course, realize that if you could see the bottom of the world, yes, there is another half. If you could see the bottom of the planet, they're in the dark all day, right? Because they're outside the half that's in the sun. There's many different ways to think of these halves. There's the northern hemisphere and the southern hemisphere divided by the equator. That's one way to think of the halves. But notice that the half in the dark and the half in the light are relative to the orbital plane. The Earth is at an angle to the orbital plane. So the bottom half stays in the dark side. Look at their winter. No sunlight, no sunlight, no sunlight, no sunlight. Finally, in the spring, you start to get a little bit of sunlight, but it's just a glance, like a little whoop, and then it's over.
Oh, the sun's dying out.
Yeah, my sun's getting ready to implode.
Dying. The world's ending.
Don't die, son.
It will someday.
I'm dead.
Do not describe what I'm doing to the sun right now. We're not going to talk about this.
What are you stealing for?
This is the privacy of our own home. Okay. So we have our many days of light on one side and many days of dark. Then we have 50-50.
It's not about right.
Here they're half and half. It's not the real sun, dude. You can look at it. It's like a 4-watt light.
I know, I just don't want like a black spot in the rest of it.
That's like in the refrigerator. Yeah.
It looks like the bottom of Africa is in the darkness for a while. Is it actually like that, or?
Well, you know, the bottom half of Africa is about the same latitude as us.
Bottom of Africa?
Yeah.
Bottom half of Africa, the same latitude.
Latitude, not on.
Latitude.
Oh, yeah.
It's the same distance from the equator as we are, so they probably have about as much seasonal variation as we do. Now, here's a cool thing. Watch this.
It's like none at all. We don't really have.
There's a part of the year that the northern is always in the dark and the southern is always in the sun, right? So our summer and our winter are opposite. I was born in the fall in my country, but I'm a spring baby in your country because of the 6-month offset. But watch this. If you're on the equator, there's 12 hours of sunlight in summer. And if you're on the equator, there's 12 hours of sunlight in the spring. And if you're in the equator, there's 12 hours of sunlight in the summer. And if you're at the equator, there's 12 hours of sunlight in the fall. Cool thing about the equator is the equator doesn't have seasons. Because the equator is 12 hours a day, all day, every day, all year. So the whole year, every day, 12-hour days. Yeah.
They have rainy seasons and dry seasons.
They do, because there is this global circulation pattern of moisture levels and so on. But if you're on the true equator, less and less seasonality overall. I was in Manaus, which is pretty close to the equator in the Brazilian Amazon. And like clockwork, every single day, it's like, up, 1 to 1:15, here comes the rain. And everybody gets in the hammock and takes like an hour nap, and then at around like 2:45 to 3, like, oh, like clockwork, rain stops, like every day, right? You're nodding your head because you've had this experience somewhere. Anybody else been to the tropics where it rains at the exact same time every single day? And the tropics, you're getting pretty close to the equator, and there isn't a lot of seasonality. You know, you can find the equator with a wristwatch. Keep walking in the direction where the days are more like each other.
Wow.
Like if you walk that way, the difference between days goes up. But if you walk that way, the difference between days goes down. So you just measure your day length, and then tomorrow, keep walking and just measure the day length. And when you find a place that it's daylight for exactly 12 hours, and then tomorrow is daylight for exactly 12 hours, and every day you found the equator. That's what it means, to equate, equator, equalize, yeah?
So when the day is not exactly 24 hours, is that what daylight savings compensates for?
Daylight savings is about which part of the day gets the sunlight and how that affects certain industries and energy usage.
Without it, what would happen though? Like
the leap year is for the offset between our calendar and the circular and the
Okay.
solar calendar.
Okay, why don't we just make it like the solar calendar?
Because it's really hard to have a 24-hour and 12-second day or whatever.
Wait,
But we could.
so if it's 24 hours and 12 seconds,
I don't know, it's 12 seconds. It's
okay,
24 hours
like
and
a
something.
couple
Yeah.
seconds, after like so many years that's going to build up and our time is going to be off.
Which is what leap year's for.
Which is why we have leap year.
Oh, okay.
But that's exactly 24 hours.
If not, you'd be like, dang, it's really hot this winter.
Yeah.
Because after a few hundred years of getting further and further from this rhythm. Yeah, so I guess the offset is that it's not 356 days. It's 356.25 days.
Oh, I see. Then there's 4. Okay.
Yeah, and it's actually 356.25001.
So then we also have to.
So every 1,000 years we have a super leap year.
What if it's super leap year?
So I guess you have 2 days in February or something?
Because 1,000 times the 0.001 to make
Right.
up 1 day, so you need like 2 leap days.
Right, so there's some year when you need 2 leap days.
If
But that doesn't happen. I don't think it's happened in our current Gregorian
humanity
calendar yet.
lasts another 1,000 years, maybe.
Yeah, we'd be lucky to have the problem. Right. Okay. So there's something else I want you to notice about our seasons. There are days when you get 12 hours anywhere you are. That's called the spring and the summer equinox. Sorry, the spring and the fall equinox. I got married on the spring equinox. It's a really special day. And then there are days when you have the longest night up there and the longest sun down here. Those are called the summer and winter solstices. And remember that on one half of the planet it's summer solstice, while on the other half of the planet it's winter solstice. The last thing I want you to notice is the angle of the sunlight hitting you. I'll find you Santa Barbara. In case you can't see it from your seat. Here's Santa Barbara on the first day of winter. On the first day of winter, look at how small our sun exposure is. Sorry, on the shortest day of winter, excuse me. I fumbled that, might be. There we go. On the very shortest day of winter, our fraction of the planet will only get about 1, 2, 3, 4, 5, 6, 7, 8 hours of sunlight. So this December 20th or this December 21st, the sun will rise right around 7 o'clock and it'll set right around 5 o'clock. And that'll be the shortest day of the year. That's what, like, how many hours is that? 7 to 5? 10 hours, something like that? That's the shortest day. And look at the angle of the sunlight relative to Santa Barbara. Look up at this pencil. Look at that angle. That's a really shallow angle, right? Like the line over there. See that? Like this?
I'm confused because like you're using the North Pole as like Santa Barbara.
No, I'm actually touching Santa Barbara with my pencil.
Okay. Wow.
Okay. And now watch.
Got a little up there.
Yeah, Santa Barbara moving more. On the roughly sunniest day of summer, this is the solstice parade. Now look at the angle hitting Santa Barbara. That's pretty close to straight overhead for my pencil, right? That's almost a 90-degree angle, right? Yeah. Also notice that it'll be really intense for like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, bordering on 14 hours that day. So it's a longer day of more intense sunlight because of the angle of the dangle. So look at this. Intense long days, that's going to build a lot of heat. Summer's hot. diffuse sunlight over short days with more shade everywhere, that's going to be a pretty cool day, not building a lot of heat. Yeah?
Oh, then why is it that like some of the the eye of some storms or something, it's like the sun is pointing directly down, or in like really really cold days of winter, like the sun is pointing directly at it. Like, why is it like that? Why does that happen?
I don't understand what the heck you're asking. I'm sure it's a good question. I just didn't get it right again.
Okay, so if it's winter and it's really really cold out, why is it? Does the sun not affect the temperature? Like if the sun's directly shining over, but it's still
There's just less sunlight total. The winter sun is lower on the horizon. It doesn't travel very far. So you see the sun at a steeper angle, and that means you're taking its circuit and you're moving it below the horizon, so the circuit is narrower too.
Okay.
In the winter, it goes like this.
Okay.
In the summer, you're taking that same circle, but now you're aiming at it.
Okay.
So in the summer, it goes from way over there, almost above you, to way over there. So it's out longer. It's not like it's moving faster or slower. We're the ones moving, and we're moving at the same speed. But you're just barely catching it off in the distance at a very shallow angle, so there's always shadows between you and the sun, and a lot of atmosphere to filter the light. And that light's being spread out over a bunch of dirt because of the angle. So winter just builds less heat. Summer has the sun directly overhead, so it's hard to hide from it. There's less shade. And it's out longer, so it's going to build more heat. And summer's hot and winter's cold. Newsflash. One last thing I want you to notice. The angle of the Earth relative to its orbital plane, it's not going to change. So watch. See how we're pointed at the map wall? Now we are pointed at the map wall. And now we're pointed at the map wall. And now we're pointed at the map wall, pointed at the map wall, pointed at the map wall, pointed at the map wall. So the angle of the dangle does not change relative to our orbital plane. It only changes relative to the sun.
So we're always leaning that way.
Yes.
You're trying to say.
Yes. We're always leaning toward the map wall. And technically, we're always leaning toward, let me see if I can get this straight. If anybody wants to know the actual way that we're always leaning that way. Like that's actually the way our planet is leaning. We're riding that ship, but that's the angle of the Earth's offset. The North Pole is that way. Actually, 15 degrees declination, sorry. There. The North Pole's that. North Pole's that. Cool, right?
Yeah.
You guys like my demo? Anyone want to talk about sunlight and day length and seasons and stuff? All right, then let's go back to the North Pole, or the Arctic area, or whatever. Check out your 4 seasons. And now think of what that does. In summer, imagine this. You see the sun, it rises, it rises, it rises, it rises, it peaks. It starts to set, it starts to set, it starts to set, it starts, and it goes, psych! And it keeps going. And then you're like, here we go. It'll be dark soon, baby. Here we go. Nope, psych! And it just skirts the horizon. Like you can just see the sun just moving that way. Like it's very, very, very bizarre.
Do some have like an hour of darkness?
As you move south on the planet, then you're getting to bigger and bigger rings of the circle. So those are starting to be interrupted by a little bit of sunlight. So if you were to travel, a few miles south of the point I just described, then it would go half a minute back. And then it'd be like, sunset, sunrise 3 minutes later. And as you go south, it's a longer and longer and more pronounced until you're at the equator and it's back to 50, 50, 50, 50, 50, 50. Yeah. So the extreme seasonality. Did you guys know that people without sunlight can't regulate their emotions as well, and depression sets in? And so people who live in the extreme latitudes, they have to go to special places that have therapeutic lighting. It's very expensive light bulbs that give off ultraviolet, so you can get sunburned inside. It's like tanning booths. It's sort of like a giant tanning, so like the supermarkets have like tanning lights.
What parts of the world, like Alaska?
Iceland, Alaska, Scandinavia. There's a bunch of bars that will advertise, like, come into our bar, it's really bright.
That's weird.
Because if you're feeling kind of funky, you got to get a little ultraviolet hit, or you get too depressed and people kill themselves.
I'll never live there.
So it affects you.
I'm not sure.
Yeah, I mean, Washington has a high depression rate. The only place higher is north. Thank you. All set? Bingo, bro. Hey, what was number 214?
She said that AP changed this to a control sign.
It's what?
The control.
What does that mean?
The teacher control.
Oh, there's another teacher there that's going to be using that classroom? And so they said, what else? So because of that, don't use my classroom over the...
I guess. I mean, I think she said she's with She's not listening.
Thanks, dude. So you asked the teacher that was in the room.
Yeah.
Thank you. Okay. Being the sun, depression, ultraviolet sunlight. Okay. Next. Look at what this does. Think of the evolutionary drives and what this creates in the wildlife and so on. If our physical reality is an extreme winter, a very, very, very sharp, dynamic, changing spring, very, very, very significant fall with these really benchmark summers and benchmark winters, how's that going to change the wilderness? Well, for one thing, nothing grows there year-round. Does this make sense to everybody? That the giant blanket of snow in the dark is kind of a bummer for the flowers? Mm-hmm. So all plants are annual, not perennial. They live within a year, not between years. All of the animals, if they are going to stick around, will have to hibernate, and that's really hard, so there aren't a lot of animals that are native here. You can imagine insects don't survive that kind of hibernation. Like amphibians don't live there, and reptiles don't live there, and birds don't live there, and very, very few, like 2 to 5 mammal species, can tough out that sort of a winter. But then imagine the summer. Like, what's a plant going to do with no dark time? I mean, in summer, I don't know if you've ever noticed, when it gets nice and hot and sunny, your tomatoes grow really fast. Imagine if they didn't have to sleep, how fast they would grow.
Very fast.
Very fast. And what if you could just show up for the good times and then bail when it gets hard so that you could go get the good times on the other side of the planet? Like, imagine that poor bird that got lost and showed up in the middle of summer and was like, wait, these plants are growing really fast and there's nobody around. We'll come back to that. This slide will come up again. So the snow starts to melt. Water flows everywhere through the landscape. And underneath the snow, what would be underneath the snow? Right, the plants that died last fall, right? So they finished their year, they dried out, they started to get cold, they got all... And then the snow fell on them, and they got frozen, and then the ground froze. Permafrost stays frozen. Frozen ground, dried up dead plants, 30 feet of snow. In the spring, the snow melts, snow melts, snow melts, snow melts, snow melt, water on the surface, land melt, land melt, land melt. And when the seeds start to sprout, they have no competition, unlimited water, and few, if any, predators. Every day is much longer than the day before. So they sprout in like a 6 hour of day, and then tomorrow they grow for 6.5 hours, and the day after that they grow for 7 hours, and the day after that they grow for 8 hours, and like, oh my God. Think about the landscape. There's nobody there. Imagine an entire landscape where all the plants have to go from seed to sprout to adult to flowers to fruit to seed in a period of what? Like 3 weeks? 2 months maybe? That's really, really, really intense. All the plants have all these nutrients because the plants last year are now decomposing. They have all this water because the snow has melted. They have all this sunlight, all this clean, fresh air, and nothing to stop them. No competition, no predators. So now imagine if you're a bird that likes to eat seeds. You show up and it's like, this is kind of cool. Everything is seeding right now with nobody there. The bird that got lost and showed up somewhere in the tundra during the glory days of summer, that was a happy bird. That bird put on a lot of fat. That bird went home like a champion and said, oh, you've all been sick and fighting with other birds and running away from the wolves? Guess where I was? I was at the sizzler. I mean, it's an all-you-can-eat buffet for a bird. So imagine the evolution of migration. Some wacky bird got lost, found this place, came home, and had more babies. And a couple years later, they were all flying with each other like, hey guys, why are we even doing this? I don't know. We're all lost. I guess we'll keep going. And then they land there and they're like, cha-ching. And they go back home. And then they're all big and fat and greasy and oily and full of sperm and eggs. And they made a lot more healthy, happy chicks that could all fly as a flock next year, and, over time. Birds that are wandering and migratory probably were generalist species that realized, we're doing really well here and we're doing really well there. And so the other ones kind of fell off with less reproductive success, while the ones that got lucky and nailed it had the most babies. Yeah?
How would the babies know to go there?
Dude, what do birds know? If you're going to ask me what they know, I need to know what they know.
But
I need to know how they know. I got to know what they know.
Since the
They don't know jack, dude. They're birds. You ever heard of a bird
I
brain?
know, but since the
You know what birds know? Eat, poop, and sleep. Breed, I guess.
okay, but
Doesn't they know?
since the ones that got lost are the ones that were reproducing, aren't those babies more likely to get lost?
Yeah, I mean, you can imagine that there was probably a wandering gene.
And so maybe
And so they were like all over the place, and a lot of them didn't come home. So the ones who wandered by following that and by following this, they're the ones that nailed it. I don't know what they followed. I have no idea how birds pull this off, but there are hundreds of species of birds that live the endless summer. And don't forget, the same is true underwater. Everybody realizes that there's still seasons in the water, right? So productivity still spikes in the ocean. You just have phytoplankton that feeds zooplankton, and that's when the whales show up. So there's that slide again that I told you would show up. let's keep traveling toward the equator here. But first, let's finish the last one. Sorry. Tundra is the most intact biome because we have nothing to get there. If there was anything in it for humans, I'm sure that we could damage it, but tundra doesn't offer us much, and so we don't go there much, and so it's basically virgin territory for the most part. There's a couple of like Inuit villages and Siberians and Mongolians and stuff, but not a lot. This is the least impacted biome. The one where we've been the least and done the least. It's the one most like its wild state. Got it? Okay. So now we travel. Sorry about the mixed signals last time. We're going to the boreal forest, which I think your book told you is also called taiga. Which always makes me think that someone's saying the word tiger in a weird way.
Yeah.
It's this dark green stuff. And let me point out that the world's largest forest is not the Amazon. Let me point out that the world's largest forest is actually Russia. Whoa. I was like, bird inside? This is the world's largest forest. That's where most logging happens. Do you guys know that most of the world's lumber does not come from the rainforest because those trees don't actually make very good lumber?
Yeah, it's all wet, right?
Yeah, so they grow really dense, hard woods, which are spectacular for jewelry boxes and desks and chairs, but you can't build a house out of that. These are the trees that build your house. Your house is literally made out of those trees. We still have seasons, but there's always a little bit of sunlight. And if there's always a little bit of sunlight, even if it's cold, trees can survive there. It's still very, very seasonal. Don't make no mistakes about that. But the winter's not so bad that it's going to be totally dark. This is outside the 30 days of dark. Every single day there's some sunlight. So even if it's cold, trees can make it. But that cold means the water will be frozen for much of the year. And if the water lives as ice, the trees got to really struggle to keep their water. There's no way to get it back once they breathe it out. So this is why conifers have needles, kids. Conifers have needles because having a leaf means you lose a lot of water. It's like having more forehead to give up your sweat with. If you shrink your forehead, you'll have less sweat. So in other words, if you shrink your leaf surface, you'll have less evaporation of your limited water supplies. So in these environments where water is really hard to come by, having big old leaves doesn't make sense. Too much sweat. Also, keep in mind that there's a part of the year when it's just not a good time for growing. There's no water in the environment. There's not a lot of sunlight. So these trees, they have a growing period and then a dormant period. It's like they're hibernating. They stop growing in the winter. When they grow, they got to get all their growing in really, really quick, right? So can we come back and talk about this tomorrow, I guess? Fine. Have a great Saturday. I'll see you at the SATs. Bye.
What? What? What?
Oh my God!
What?
That was my hand. I'm going to throw it. My B-dog.
How mad would you be if, like, sometimes during a presentation I just grabbed the bottle and sprayed it?
I'm mad. I don't get mad.
You don't get mad. You seem pretty mad. You don't get mad.
No, but I do get even.
Oh, you get even.
That's right. Right, Paige?
Where's Veronica?
Yeah, you see it even.
Well, I'll see her in 4.
Your system seems really good, but like you don't get tired of the same videos.
I'm coming. I'm walking. Oh, good.